Hello, so today's topic is agentic and self-improving prompts. The question will come that why vanilla prompts will not serve our purpose. In case of vanilla LLMs, we generally use direct input questions or alert and fire it to single LLM call and then we get the answer. Actually all the LLMs are very good, very powerful but fragile because mostly they answer based on what they have seen during the training. But the scenario is highly complex these days because in the real world scenario, facts changes continuously. So we can say that it is highly dynamic. Every day you can see that new type of fraud patterns in the banking area, new type of rules, regulations, inventions in IT, healthcare, banking, all other domains. So we need to incorporate all those changes in every area, in all our applications. So our system should be updatable according to that. And next important thing is mistakes are costly. Suppose we wrongly block anyone's credit card, we give unsafe medical advice to any person, then it will create a lot of problem. That's why we need large language models or generative AI type of systems which should be reliable, effective and robust. And it should be auto updatable according to changes, dynamic changes. So that's why we need agentic and self-improving prompts. Here you can see the complete pipeline for agentic and self-improving prompts. This pipeline is actually divided into two parts, agentic part and self-improving parts. So in the agentic part you can see that it covers three different types of operations. First, we take the input questions, alerts or anything or queries. Then we plan. So what is plan? Plan means we try to identify all the required information to take the decision, to check the financial fraud, to make any decision about healthcare situations, to update our software system. So we need a lot of variety of information. So in the planning part, we put all such kind of prompts related information and all such kind of prompts which can be helpful in properly planning all those information. Second part is act, tool and data. Here we collect all those information from different tools and databases through direct call or through API or through any other way. And we also have to collect the evidence about the initial decision. So we collect all those information. And after that, at third phase, we prepare a draft. This draft is a structured draft. So we collect and organize the entire information in a very systematic way. After that, self-improving parts takes the control. So self-improving parts are actually works like a built-in quality controls, built-in quality control kind of system. So again, it uses three different phases. The first phase is critic. It reviews that what you have collected and put in the draft by using rubrics. So for that, it uses different types of rubrics, like to check whether the information you collected covers the requirement for your actual task. The informations that you covered is correct or wrong. The decisions you have made lacks some information or it is complete, and then final organizations of information is controversial or it is complete or it lacks something or orders are not in a proper way. So everything is checked by the critic part. Next part is repair. So repair actually fixes all those problems what we get. So for example, we get some problems in the critic, sorry. So in the repair part, we generally fix all the problems. For that, we add all the missing information, we organize the missing part, we correct the decisions, like that. So based on the task, the repair part will be different. And next part is guardrails. So guardrails are actually works like a final check. Whether you after repairing the information is properly organized, correct, and we can send it to final LLM or not. And after that it generates the final calibrated answer. So this is the process of agentic self-improving prompts. Now we will try to understand the entire scenario by using a simple banking fraud monitoring system. I have taken a very simple case just to explain the concept of agentic and self-improving prompts. So how the banking system works? They first maintain the transaction flow online log monitoring system. It will continuously monitor your all transactions. Second part is alert engine, rule or AI based. So this is the scenario of alert based system. So they generally checks multiple kind of things based on rules, like whether the transaction is above threshold, whether there is a geo jump. Geo jump means suppose you are purchasing something at city C1 and again within 2 hours you jump to city C2 and made a transactions of heavy amount. MCC means merchant category code. Generally they use banking system uses 4-digit category code to represent different transactions like online purchase, offline purchase, ATM withdrawal, international or national transactions. So based on that type of or category of transactions, banking system considers some of the transactions risky. For example, ATM withdrawal or online transactions, international transactions. So in the current case, maybe like suppose you withdraw some money at city C1 and after 2 hours you withdraw money at city C2, which are actually 2000 kilometer apart, and just after 2 hours you withdraw. So this kind of transactions will be like a fraud kind of transactions that that will alert the banking system. Again, the next is a velocity of transactions, like how much amount you can transact. Another is structuring, like how many deposits just below 1 lakh or 100k or reporting limits. Based on all those informations, if the banking alert system or alert engine finds that anything is suspicious, it will create the alert. And once the alert is created, it will go to the fraud analyst. And in our case, it will go to our agentic AI. I discussed earlier in this agentic part, it will do this kind of operation. So pull the customer information, KYC, profile, past transactions, customer signals like MCC risk, velocity, geo distance, sanction check. There may be some rules like a possible account takeover, restructuring, sanctions match, and there may be some confidence score about the findings and client score. Based on that, it will prepare the entire documents for this. After that actions will be taken directly by the system. But in our case, actions are controlled by self-improving prompts like critique, repair, and guardrails. But here, in a normal banking norm, generally they take two different types of actions. First may be the immediate actions that may be safe or reversible. For example, set up authentication. Okay, verify through OTP that you did this transaction. Soft block of card. They will ask contact number. Or when you approve or disapprove, it may hard block, freeze, or report this transaction. And after that, it will send it for case review and audit for final inquiry purpose. So this is the process of manual banking fraud monitoring system and detection system. Now we will try to develop a similar system by using agentic and self-improving prompts. So this will give the overview that practically how we can solve such problems. So suppose we have an example. A bank gets an alert that customer spent 8,000 rupees at a cafe in a Mumbai at 8 p.m. and within 4 hours two transfers of 1,50,000 or 150k each were made from Delhi using the same amount. The distance between both cities are around 1500 kilometers. So within 2 hours or 4 hours, if you are doing so much transactions, then generally it creates, and the velocity of transactions is also too high. It will automatically create the alert for banking system. So it will send this to our system. Now suppose we try to solve this problem by using simple vanilla LLM, then what will happen? So we will use the prompt like, is this fraud? What should the bank do? Then actually the traditional LLM may respond like that. This looks like a possible fraud because the customer was in Mumbai and then in Delhi in a short time. Actions immediately block the account and notify the authority. Here, this is not correct because here there is no consistency, there is no rule check, there is no proper verification, there is no systematic evidence analysis, there is no check that where the rules changed or where something permits or where interaction of some rules have some meanings, it is not checked at all. So that's why it gives a wrong result. But now we will see that how agentic LLM with self-improving prompts will solve this problem. So as I said, first part is agentic part and second is self-improving part. So agentic part will do three operations. First, plan. The LLM decides to fetch KYC transactions, compute GeoJump, velocity, MCC risk, sanctions, related information. And act part will actually try to collect the information as I discussed earlier. Try to collect the information from different devices, database, APIs like GeoJump. It identifies that there is a 1,400 kilometer jump in 4 hours. Velocity 300k rupees transactions in just less than 6 hours. MCC like 4829 means money transfer happened. This is high risk considered by the bank. And sanctions, there is a no sanction on that person, that customer, so no match. So those kind of informations it identified. Then it will draft. So drafting part will identify that hypothesis, possible account takeover, may be possible, confidence is 0.7, action, immediate hard block account. But if we just depend on this part, then again we will face some issues. That's why self-improving prompts plays its role. So self-improving will start with critic. So critic part will check that if missing sanctions field, no, present, not present, means the person's record is good. No evidence issue listed. Person's record is again good. Unsafe hard block confidence is just 0.7. According to rule, it should be less than 0. It should be more than 0.8. After that, based on the critic related information, the next phase is to repair. So repair and then apply the guardrails. So repair part will check that possible account takeover based on jump MCC in less than 6 hours, confidence is just 0.7 and signals is like this. So it just repairs all those things. Sanctions hit equal to false. So this part they repair and then again repair some immediate things like contact customers for step up authentications, flag account for monitoring, and with approval hard block and escalate the law enforcement. So evidences, it says collected that what are the evidences that is based on the revised actions in the repair phase. So it is like a Mumbai cafe transactions followed within 4 hours, high risk MCC money transfers and high velocity transfers. That's why it says to check something, but instead of blocking the card, it says that contact the customer for setup authentication and flag account for monitoring. So already understand that why this is correct. First is evidence based, all risk signals, and second is self and calibrated, no irreversible hard block, compliant sanctions checks included, auditable, JSON structure ready. Means here we use the JSON structure to maintain all those things, so it is easily auditable and consistent. Now we will try to understand the actual pipeline. So this is the actual pipeline of agentic and self-improving prompts. So first of all, we will try to understand it how it is different from the vanilla pipeline. Here first, user takes the questions, apply the single prompt to LLM, LLM generates the answers, and then output may have risk like missing facts or signals, inconsistent runs, unsafe or over-eager actions, or hard to audit because once it generates the answer, final answer, how you can audit based on just a question and this answer, that what goes wrong in the entire process. So this type of problem you will face if you use the vanilla prompt. Now in the agentic and self improving pipeline, how the system works: takes the user questions and alert that is generated by system, plan like already discussed, then act call tools, KYC transactions, vital labs, collect all the informations and then draft everything like structured JSONs, hypotheses, confidence, evidence, actions, immediate or with approval, means such kind of actions just plan and then it will enter into self-improving part from here. Critic or rubric, it checks that whether gaps are there in the actual rules and the findings. It repairs, fill the missing signals, regrade the risky actions, clarify the evidence, and if it looks good, like then bypass the repair. Means you don't no need to do repair things because everything is good. Then programming guardrails will be there. Determine the safety check that whether it passes all the safety related parameters or not. After that, So once you pass the informations from these guardrails, you will find that the output is like a calibrated audit ready output, and it contains the complete signals for safe actions. It contains the transparent evidence, so you can easily audit it. Then it will send it to LLM, and then you can get the final answer. So this is the way. So that's why we can get the quality gap. Now let us discuss the entire scenario through code. So I have used the same problem, banking fraud detections, through code. So first part is like you have to call all those information here, and after that you have to configure your large language model related things. So I have just used the Llama 3.1 8 billion instant model. I am using the free version of this part. Now the data part is started. The customers. So we have three customers: customer 1001, customer ID, name, date of birth, risk tier, country, KYC status, account IDs. Customers may have multiple accounts. So we have three such kind of customers. And then again account. So account ID is there, customer ID, account type. So what is the type for that account? Another account like saving, checking. So those are the account types. And then transactions. So transactions details are there. So how much amount the transactions, how much amount is used in the transaction, currency type, MCC, merchant, from where, which are the target for the transactions, and then longitude, latitude to collect the geo jump country related information. So we have informations for three accounts, and then sanctions. We are using the sanctions also. So here we found that sanctions are there for only two people. So high risk MCC, generally debit card withdrawal, or international, or means, or some online transactions are considered as risky transactions. So here they have used that this is for debit card and this is for online transactions. And then threshold of money like 100k, thousand, that we consider like a threshold. If it goes beyond this, then system will generate the alert. Then we collect some utilities like what is the distance between 2 points if lat longs are given. Another thing is like date time formatting related things. So hours between two transactions we are calculating. Then we are taking the last geojump kilometer identifications. Then we are checking that whether the entire transactions in these functions, we are checking that entire transactions are beyond the limit, and window hours. So all related informations we are collecting. Finally, we are using those to collect the velocity, like how many amount is spent during a particular time window. Then MCC risk, like whether the transactions are risky or not. Then sanctions, whether those persons are listed under some sanctions or not. So such informations actually we collected through code. And after that we use the tools part. So we shall collect all other informations related to get the customers detail, accounts, transaction details, risk signals, all those informations, check the sanctions. So all those informations we collected. Now LLM call. So we call the LLM. Here we just use the call LLM functions to call the LLM. Then we are using tools schema for functions calling to decide that how we can manage all the information or structure all the informations here. So it is just prepared the way we put all the information in the JSON file. Then the main resolver and critic system starts by LLM. So here we are saying to the LLM that you are a financial crime resolver, precise fraud or AML case trial agent. Your objective is to means given an alert, description, suspicious patterns, call tools to fetch the KYC accounts, produce the structured case dispositions with the evidence and safe actions. So what are the different schema that we are providing? We are giving that. So we inform the LLM like you are the main agent to handle all those informations with all those qualities, and based on that we provide the data, what kind of actions you have to do, and then some mandatory behavior we fix that you have to check those kind of things. No hallucinated data, use only tools output. Then we put some other informations also, like validate the draft JSON using the following rubrics. So these are the rubric rules that we are passing here. So now we are doing LLM orchestration. We are collecting all the informations for which we decided the functions earlier: get accounts, get transactions, risk signals, etc. Then we load all those informations given in the JSON file. Then we prepare the LLM draft with all those messages. And after this critic part, we apply some programming guardrails like I already discussed. So if the confidence is 0.8, so now in the current demo we provide two different cases for this information, and then we run all those two cases and then check that how the system performs. If you see the results, you will find that it collected all the informations, stored everything in the JSON format, apply rubric and critics, all the rubrics for given critics, and then corrected the informations. So here the you can see that the final decisions came like possible accounts takeover due to high risk MCC and GeoJump, customers to be contacted for additional authentication and needs to follow up customer response to additional authentication, review the account activity after 72 hours. So this kind of decisions provided by the system. So I hope you have understand the role of agentic and self-improving system in the development of a basic fraud detection system.